I want to find the carbonate ion concentration of 0.050 molar carbonic acid. Now I need to know what are my equations so that I make sure I'm doing this correctly. So I have carbonic acid, so if I have carbonic acid, and I'm going to leave off the states for the time being just so it's a little quicker. I'm going to add this to water. I know it's an equilibrium. I have to add an H to the water to get the hydronium, and then I need to take away an H to get HCO3 minus. Well, when I do that, I know that there is a Ka value for that equation. So I went and looked it up, and it is 4.3 times 10 to the minus 7. Well, this is great, but I'm looking for just the anion, and I don't see that anywhere in this equation. So let's take what we ended up with, which is the HCO3 minus, and now I'm going to put that in a new solution with water. And again, I'm going to get a hydronium ion. And this time I'm just going to get CO3 2 minus, and this equation now has a new Ka value, which is 5.6 times 10 to the minus 11. I've got two equations, so it looks like I'm going to have to work two problems. So I'm going to do it first with the first equation. So I'm going to put a 1 up here. And then I'm going to do it again with the second equation. So why don't you try to set up the first equation and then come back and I'll walk you through how hopefully you got it. So I wrote down the reaction. The only initial concentration I'm given is for the actual carbonic acid. So I have 0 and 0 on the right. Remember, I'm going to take away the X on the left and add it on the right. So here's my equilibrium constant line. Now I'm looking at a Ka, right, because this is an acid. I'm using the Ka value that was originally provided to me. I set it equal to x squared divided by 0.050, hoping that I can do the approximation. Here's the molarity that I got. It is less than 5%, so we're okay. But now, this is the molarity for what? For the hydronium ion and the HCO3 minus. That's not what we want, right? We want the CO3 2 minus. So I'm going to need to do this again using this number that we just obtained right here, using the second reaction. So try that one as well, and then come back and check your work. So here's the second reaction. Now remember, the initial concentrations, we actually ended up with the hydronium and the HCO3 minus. So I added that for each one of them and none of the anion that we're looking for. Again, we subtract on the left, we add on the right. So I've got these. I stick it in the Ka2 for the second reaction. Now, I'm hoping that the approximation is going to work because I'm using teeny tiny numbers, right? So I'm going to try that. So then that just means my Ka2 is going to equal to the concentration of the CO3 2 minus. When I check, this number is considerably smaller than 5%. So then my final answer is the 5.6 times 10 to the minus 11 molar.